it's very publicly known what exactly is captured and what is allowed to be used in which way. I think that is first and foremost super important to kind of have that psychological safety.
Hello, and welcome to Hangar DX. This is a podcast about developer experience and how engineering teams solve productivity challenges at scale. I'm your host, Ankit, a co-founder of Aviator. At Aviator, we are building multiplayer coding platforms and other developer productivity tools. Today, my guest is Moritz, and we will be diving into some of the research that Moritz has been doing at Meta. So, Moritz, before we get started, can you please introduce yourself for the audience?
Hi, Ankit. So my name is Moritz Beller. I have been at Meta now for almost 6 years. Before that, I have an academic background, always very interested in the areas of productivity for software engineers.
So tell us a little bit about how your team functions and what are kind of like some of the objectives of your team at Meta.
The team that I'm currently in is called Developer Insights. So as the name implies, we kind of closely work with DevX teams across the company, but also different product groups to basically find and scale insights that make developers more productive. That can be behavioral aspects, but it can also be extremely technical, right? And things like improvements in our integrated developer environments.
Cool. Okay, so the main topic we're going to talk about today is one of the papers that came out about Diff Authoring Time, and you've also talked a little bit about it more publicly. I want to kind of for the audience, most of them would not be familiar with this thing, and probably we're going to call it DAT or DAT, I don't know, during the conversation.
Either is fine.
So maybe first kind of talk about a bit about how did this come about, and then help explain at a high level what it means.
So I think there are a couple of themes that were happening around end of 2022 that kind of all sort of led to the development of DAT. I think people were doing remote work at a scale that was unprecedented at the company, and so one of the themes that emerged there was like, hey, are people actually working effectively and productively from home, right? That had been going on for some time, so there obviously was enough data in a sense to be able to quantify that. Just really didn't know how. The other thing that I think happened in parallel is that you saw companies like Meta, Google have very strong experiment-driven culture in their products, which means before a feature is being launched, there's rigorous, or launched widely, right? There's a rigorous A/B testing where you have an A group that's exposed to an intervention or treatment, and you have a B group, generally speaking, that doesn't see it. And you have a couple of metrics that you set up to see what the effect of the experiment is that you're launching. However, we also realized that our own internal development culture in the developer experience, right, DevX space and in the productivity space was lacking in that regard. And so we had this very strong, scientifically inspired external culture, but internally I think the best we had was basically surveys or expert opinion. And both of these things, are susceptible to certain biases. And so we wanted to move to a world where we're not beholden to those biases, and we can, kind of ideally even reuse this very strong experimentation framework that we have available externally for our internal development. So, for example, you're making a change to Hack, right? A lot of code at Meta is written in Hack. How do you assess the productivity impact of that feature internally? And can we do it in a way that's basically free of confounders, right? That is, I think, sort of the general state of the world that this started to be developed in.
Interesting. So tell us a little bit more about Diff Authoring Time.
So Diff Authoring Time is a very simple concept. It tries to measure the time an engineer spends developing a diff, and that is the active work time, right? So you're going for a coffee break or something, this should not be part of that in theory. Ideally, in a perfect world, we would capture sort of all of the time that goes into creating a diff, and we'll talk about what a diff is very soon. That could encapsulate, right, meetings, docs, sort of like somewhat related tasks that are in the space. Of course, you see this is like a pretty murky concept, although the core of it, the core engineering part, would typically be what you're doing in your IDE. A diff then is, which is the main concept of DAT, is basically Meta's equivalent to a pull request. It's a self-encapsulated, self-contained code change that is complete, usually with a title. It has its own reviewer. It has its own test plan. And now, of course, sort of a diff can be a bug fix, or it can be a feature add, or it could even be something like, better engineering related. So there's like different things that it could mean, but it's essentially a currency at Meta, if you will.
Interesting. So why focus on this unit versus like a larger feature or a sprint?
So I'll be honest. Part of the answer to that is it's easier. It's often, right, if like we're doing that, especially with LLMs, right, that's possible. You can actually kind of categorize what sort of, and quite accurately so, what sort of thing this diff tries to accomplish. But apart from that, like I said, it's just a kind of currency at Meta. Very crudely, if you look at what is the output of this organization, at a very, like at a 40,000 foot view, you can probably see the number of diffs is somewhat like correlated to that. And everyone talks about it at Meta all the time. And code, of course, at Meta is very important. So then if you're speaking about a diff, right, yes, a diff can be very different things, right? It can be a one-liner fix, or it can be a couple thousand lines, although usually, kind of the same principles as for pull requests apply. So there's a natural distribution of what a diff would normally look like, and so that's well understood, and it's effectively currency at Meta, if you will.
Interesting. Okay. So I also remember reading that this is the 5th version of DAT at Meta itself.
Now even.
You're at 6th version. Okay.
Yep.
So what changes every time? Like what's kind of like, what's the evolution like?
Initially, we had a pretty drastic architecture change because we were trying to measure this under the hood at the file level. So basically what we were trying to do is we would see in the IDE which files a person was working on, and then we would try and match it to the files that were edited in that diff, right? And so if there was a high overlap, we would say, well, we'll take the time that the person worked on in those files, and we'll just kind of sum that up, and that will be the DAT for this diff. Now, of course, that has the problem that people tend to work on kind of, the same files all over again. It's basically part of the same subsystem. And so that is not a very accurate way of doing that. So that was the first version, which we actually never published. And then we went on to the core realization that, hey, if you have a little bit of telemetry integrated in the IDE, you can actually obtain the state of the repository that you work on, particularly the commit that you currently sit on. And also, when people are then committing, you'll get a new hash that's a unique identification mechanism for the work that you've just performed. And then we can aggregate all of the hashes that make up one diff. So it's basically between a diff and a commit, it's a 1-to-n mapping. And so we can we then have a very precise way of knowing exactly what was happening at that time, and we don't need to rely on this kind of fuzzy matching by files. So this is the change that happened between version 1 and 2. And then kind of what I was saying earlier, hey, like there's a lot of things that could go on outside. It's generally along 2 axes, or actually 3, I should say. Either make it more precise, we've covered that, or number 2, include sort of more tools that are kind of in the diff preparation phase, or like preparation, or basically like a post fix. If it goes through release and there's some tools that would need to be covered. So an example here would be you have a data scientist, they're doing some SQL work, right? And they typically do that in an interactive playground before creating a diff. Ideally, we cover this tool. Or I think I earlier mentioned tasks, right? We have task management systems, of course. Can we connect the work that happened on that task to the implementation of the task in the IDE? So this is number 2, which is basically cover kind of more auxiliary tools. But then number 3 also is cover more IDEs. So Meta currently number 1 IDE is VS Code. We have our own fork of that. But also, of course, as you know, we have iOS apps and Android apps, and so then the kind of the third pillar there is natively integrate into those so that we have the same level of fidelity as we have for VS Code.
Interesting. And how long how long have you been capturing some of this telemetry, and like kind of if somebody was to look at this type of a data, what is a typical duration they should be looking at?
You mean for analyses?
Mm-hmm.
That really depends, right? If you're doing case studies, then and you want to see longitudinal effects, then typically a couple of months is a good time frame, depending on, hey, I want to see the effect of like work from home or something like that. If you're running high powered experiments, which we can also do, then sometimes even a couple of weeks, 1-2 weeks is enough to just get statistical significance, and you'll see the effect size.
Oh, very interesting. So you're saying like in 2 months you can actually get decent amount of data to do some analysis.
Absolutely, yeah. And then, I mean, at the end, it depends on how like with all of these, right? It's a statistical property, so it depends on how many people are exposed to the treatment, how large is the effect, and then.
I see. So do you recommend to kind of like, if somebody was to use these tools, that they should do some sort of like control testing or like measurement versus sort of like having just trying to get the data in a general way without doing any control testing?
Yes, so we started out with not even thinking about this experiment mindset, because there's actually a lot of things that you can do, right? If you're clever about it, you basically just need a data scientist. You can kind of post hoc do case studies that also give you statistical significance. I think that is probably the easiest way, and even shy of that, right? You can kind of just monitor trends. So, for example, you could see, as the company is growing, right? How is this very high level productivity metric doing? Where does the trend line fall? And just to kind of keep a tab on what's going on there, that makes a lot of sense. You don't even need, it's just a dashboard that you need at this level, right? Then you go to the case study level, where, you do have confounders that you can't necessarily always control for, but that still gave us, I would say, at least 50% of the analysis are done on this level. And then eventually when you're ready, right, and if your infrastructure set up, etc., you can actually do experiments.
Very interesting. So everyone agrees that software engineering is a fairly complex system or like work, right? So it's like multidimensional. It's not like kind of like an assembly line, right? So there is a lot of workflows, including context switching, pair programming, research time, all of those things. How do you take into account those things?
Yeah, that's a
Or
great
if
question.
you do take into account those
Yes.
things?
So we try to do as much as possible of that. Obviously, there are limitations to that, right? I think, well, never say never, maybe, but whiteboarding time is going to be almost impossible to capture just because we want to do this in an automated way. We don't currently have the tools to do so. Same for pair programming, because we don't want to record people like their webcams while they program. That's obvious. And you just have one Unix name that's associated with it, right? So we kind of, and it's actually honestly also not super widespread at Meta. I know there's some, stories about, especially I think at Google, people that tend to do that more often, but at Meta, I haven't seen so much of it. So we do accept kind of naturally some inaccuracy around that. However, we're trying to push the boundary. So even for something that seemed impossible when we started out with this 2 years ago, even with meetings, if you have an LLM that analyzes the meeting, it's now possible in an automated way, right, to connect this meeting to the diff that you're writing. And so if the LLM is a bit clever about this, it includes timestamps. You can map those timestamps to a duration, and you kind of assign the duration onto the diff. So I think we're really pushing the boundary on what is possible there.
Interesting. So also, given that you brought up LLM, software engineering itself is changing pretty drastically. How do we think about some of these metrics? Do they still play the same role when it's like AI assisted development? Do you have to kind of like add certain factors for accounting for kind of like measuring this?
Yeah, absolutely. I think you do. And I think Diff Authoring Time never told the whole story, obviously, right? But I think this metric in particular remains very relevant. Ideally, right, if you think about it, it should go down over time as AI assistants help you author code faster. But we'll see about that.
I mean, like now we're getting to a place where systems are automatically generating PRs without human assistance, or at least with a single prompt.
Exactly. Yeah.
Right? Like some of these things will definitely become more interesting.
Yes. You could think of DAT for, different agents, and then you can compare the agents against each other. So
Right. So I'm assuming the DAT doesn't take into account the review times and the revision times for changes.
It actually does. So we split up these components. So if you're not interested in that component for whatever reason, right, because you're only interested in sort of the original authoring, then you can split that out. But if there's actually we even track the reviewer's time. So if there's significant amount of rework in that diff, you can see that through DAT as well. Because the idea again is like, this is time spent on this diff, right?
Interesting. Okay. So moving on kind of like a little bit towards, understanding some of the case studies and work you've done around it as well. I'm going to just read it out. Kind of like there was some impressive productivity gains mentioned at some point in one of the papers, like 14% from mock types, 33% from auto memoization, and 50% from code sharing. Can you walk us through a little bit of these case studies? What do these things mean? How they were used? How they were designed?
Mm-hmm. So I'll use this as a plug for the paper, which has all of the details on this. But yeah, I'll go through these. So maybe let's start with code sharing, because that's probably the most high level. The idea there is that Meta has a bunch of apps, and there's typically an instance of the app for Android and iOS, right? So let's take FB Blue. It'd be, obviously, since it's essentially the same product, there's an opportunity to reuse, which we're tapping into. Now, the question is, typically it's a bit more difficult to come up with kind of a generalized framework and also to use that. However, it has advantages, right? If there's a bug, you only need to fix it once. The apps in the two different ecosystems will feel alike, etc., etc. Now, the question that we wanted to answer with DAT is how much are we actually on the kind of production engineering front are we saving through code sharing? It's an interesting study, this one, because what we did is we calculated the counterfactual DAT if someone had to essentially implement this feature without using that code sharing framework that exists. So we basically know how long we know very precisely how long it took for them to develop it using the infrastructure that's there. And then we also have sample diffs of people not using that framework. So we can essentially then compare, hey, if you're DAT in the Android ecosystem, right, and there are many more confounders than just that because there's subparts of the system, et cetera, et cetera. But if you're in the Android system and your DAT is, let's say, an hour, we know that replicating this for iOS would take you 1.2 hours, something like that. By basically doing code share, we're saving those 1.2 hours. And so we can sum that up for every single diff. And of course, that doesn't always need to be positive, right? Essentially, you would need to take the total sum of all of the code shared diffs against the initial development effort of that code sharing framework.
Can you describe a little bit more about code sharing framework? Are you talking about like you have large amount of repos and people are like using existing libraries for development, or are you talking about using patterns that exist in different code bases and applying similar patterns in their software development?
It's really the first in this case, right? So you can think of like a library of, say, Facebook components.
Got it. Okay, interesting. Do you want to share any of the other things like the auto memoization or mock types?
Oh yeah,
Examples?
totally. So I think auto memoization is a very relatable one and a fun one. So this is for React, where Meta famously open sources the language and also the compiler. One thing with React components is that you used to need to do memoization yourself. You need to basically hand roll it. What is memoization? Well, it's like kind of caching you can think of, but on the UI level. So of course, anyone who knows React knows that it's similar to HTML, really, it's a deeply nested structure. And so a component that's high up in that hierarchy needed to be re-rendered, and you did not do memoization or you didn't do it correctly, that was very expensive. Now, of course, there's the saying, right? There's only two hard problems in computer science, which is, I guess, naming things and caching. And so, like, memoization definitely is an instance of caching. So, things went wrong. It was very costly to do that. So the hack team thought, hey, maybe you should help developers there and just basically integrate that into the compiler and do it automatically. And what we've seen in that study is that by the hack team enabling this feature, which is, by the way, not in the current open source release of React yet, we were able to save 33% of just pure development time. It doesn't even take into account all of the bugs that were prevented from that.
Okay, that's quite impressive. Okay, kind of like just moving on a little bit, is there anything which was counterintuitive in the findings through these case studies? Like, things that you had some theories for and they kind of like were proven wrong, or like maybe there were like any surprises?
Yes. So it's a surprise, although when you think about it a bit longer, it's not really a surprise anymore. Initially, I think we were looking at the wrong set of features to experiment on, probably driven by our product level experience, where when you change the location of a button, I think there's this very famous paper from Bing, or change the color of the button. It might also be Airbnb. They saw these like kind of 1% something effect sizes of people clicking more. We tried a bunch of similar things and there just was no effect size whatsoever. And then we thought about it, like you look at the developer workflow, everyone has their own idiosyncrasies, right? Everyone is using the IDE in different ways, a subset of features. So basically, abstract way, the space is just much larger, right? Than when you're on a relatively confined website, say Google. It's like really not that much you can do on that website. But if developers have some kind of problem that that they don't like on the UI, they typically find very intelligent ways around it. And so doing these kind of small optimizations didn't seem to yield any effect sizes. So on the other hand, right, then like if you do these kind of language level changes or framework level changes, those had much larger effect sizes than we would have initially guessed.
Fascinating. Okay, so I want to talk a little bit about, this whole idea of measuring productivity as a concept, and kind of like, there is these whole push back against, measuring productivity. There's the concept of Goodhart's law that people try to kind of like game these metrics. There's obviously like things like Dora metrics as well. Can you talk a little bit about like kind of how does like, your team or kind of like Meta work with it? And more specifically, especially for DAT, like I heard that you folks don't measure at individual level. What does that mean for kind of like psychological safety for the team? And I'm assuming people like developers would know that, okay, there is some instrumentation and telemetry through their IDE. So does that impact how developers operate? And maybe share a little bit about your thought process there.
Okay, wow, those are many questions. I have many thoughts.
Okay.
Let's start from the back, maybe. They do know it's very publicly known what exactly is captured and what is allowed to be used in which way. I think that is first and foremost super important. I think also, when you hear kind of the state that Silicon Valley is currently in, I think that is very important for people to kind of have that psychological safety. And it also helps with gaming. On the other hand, I also think that time, in a sense, is the most ungameable thing that you can do. Because if you try to game your time, it's going to hurt you the most, probably. I mean, it's easy, right? You can, like, if you wanted to, you can create more code that's not necessary, etc. But at the end of the day, if you somehow, try to game your time, that will hurt you the most. And also, there's an upper limit to how much you can game the time, which is, at max 24 hours. And so, at the same time, it's not necessarily good for you if you spend a lot of time on a feature, right? In a case, since that's actually counterproductive for DAT, so you can't really do that much. I think there's also been research by other people, including also mine, that showed that time is the most correlated with actually self-perceived productivity. So I think,
Interesting.
it's probably a reasonable choice.
So, I remember there was also this metric I heard about from Meta called DDM, which is diffs per developer per month. And I think like you have DAT, all of these things are diffs related. One of the things we talked about, I remember in many of these sessions, and like generally is like acceptable, is like you should not measure the commits or pull request by developers, because then you kind of like start gaming it by creating smaller changes and then you have more pull requests, right? Some of these things I feel could possibly apply here as well.
That's absolutely true. So if you do think about it, though, if you have a metric such as DEDM, that goes up, right? So you'd think, well, developers are more productive. If it's only gameable, you would see exactly the same movement, but in the other direction in DAT. So you would need. So if you have those two metrics in place, you basically exclude this whole set of gameability.
Interesting. And any thoughts on how do these metrics compare with Dora metrics or any other kind of like more commonly used metrics like that?
Yeah, I think Dora and the space framework as well. I think they basically give you a set of metrics to choose from, which I guess DAT could fall under. So it's really up to you, I guess, how you instantiate these frameworks.
Okay. I guess like, yeah, lead time for change is probably something which might be closer to
Exactly.
DAT in some ways, right?
Yeah. I think the general category that they would fall under in these frameworks would be velocity.
Interesting. Okay, kind of like going a little bit towards like practical application. I know Meta internally works on, like at least externally as we know, as Sapling, or sort of like their own internal mercurial based source control system. Any thoughts on like how somebody can implement something like DAT measurement in a Git based system?
It's essentially the same, because I think the idea, right, of like, hey, I have a commit. Git also guarantees that hash is unique. I just need to know what the current state of my repository is. And once I do that, right, I can then match that. And I'm sure something like GitHub would, track sort of the pull requests and what commits the pull request is made out of. So you could like basically do exactly the same thing. And I honestly think that there are many both companies as well as even universities who would have enough kind of developers to actually make this a worthwhile endeavor.
Interesting. Are you familiar with any tool or product that does this?
I'm not aware that anyone else has implemented it.
Okay.
So yeah, if someone listening wants to do that, I think is a cool idea.
Interesting. Tell me a little bit about the qualitative side of this, right? So a lot of this sort of like you do collecting through instrumentation. Um, do you also take feedback directly from developers? Like, how does that play into any of your research work?
When we started out, this was a big challenge. If you try to convince an organization that works on expert judgment and has obviously worked very well based on that, then trying to pivot that organization into a more rigorous metrics driven uh, basically methodology yields some let's say pushback. So basically you ensure that your metric is aligned with your incentive, and you convince people that that is the case. And at the same time, I think metrics only take you so far, right? Some of the step changes that are being made, I don't think would be captured in the metrics that exist, because they typically just tend to describe it's hard enough to describe the world today. Then if there's a new invention, then typically the metrics at least initially fall short of that. So I think the real answer there is you need to convince people to use the metrics where it's applicable, and not to kind of stifle innovation just because everything that we do is now about improving this metric.
Right. I know you touched a little bit on this, but can you give us like examples of things that came out of this measurement in the sense, like not just like, the results of it, but are there specific investments or decisions that's been made because now we know the outcomes from these experiments and metrics?
Yeah, so I can't talk about kind of very concrete ones, obviously, but I can give you the class of kind of decisions that are powered by this. So we were talking about these kind of small, low-level improvements, and we've seen sort of like how large actually some of the effect sizes were for framework and language level improvements. So generally for planning, right, there's been a push toward these big bets slash big rocks. And DAT has kind of really, made the case for those.
Sorry, made the case
For like doing bigger, sort of bolder investments, rather than a lot of the sort of, oh, let's tweak this little thing a little bit.
when you say bigger investments, you mean like investments in the tooling for developers?
Exactly. So it's a huge case, right, for like what leverage platform teams actually have, and I think in some sense they are not always aware of.
Right, right. I can imagine like also some of the things that you brought up from case studies could play into that is like how do we kind of like improve memoization? How do we kind of like improve code sharing? Those kind of things could be also
Exactly.
part of it.
And then actually once you have that, right, you don't need to always run a case study on this. Oh, this falls into this class of improvements, so there's no need to set up this rigorous experiment for it, because we already know what sort of win we will expect from it.
Amazing. Okay, Moritz, I think we're coming close to time. So let me kind of like try to see if we can bring some more learnings for the folks. Like, so maybe folks who are just starting as engineering leaders want to be more data driven. Do you have any advice for them?
What's basically good practices to, and also very low cost typically, is just start out with a survey, because even though it's qualitative data, you can kind of convert it into quantitative data, which is very helpful. And I think what we're this is basically how Meta's operated for a very long time, right? And assuming that the right voices get heard, which a survey would normally allow you to do, then that's a very good step. I will also say that I think the kind of the general space of developer productivity is fundamentally kind of the problem of knowledge worker productivity, which is unsolved, right? I mean, there are many people that tell you kind of different things, and I think in some sense even frameworks like Space and Dora sort of make it seem like that's solved, but no. Like also DAT, right? It's a proxy for something. Don't over-index on any proxy, whether that's a survey, whether that's that's a metric that seems to be objective. But usually you can kind of, and that's actually the reason why I'm in the space, is you can actually do a lot of things even if you have imperfect information, as long as it has a tendency to, kind of converge to the truth. So especially if you have a survey and you have objective measurement, you can combine those two and triage. And I think that's then the next step.
Very interesting. Okay, and maybe sort of like last question. So now that DAT exists, what's next? What are like some of the more interesting open questions you see in productivity measurement that you're excited about or you're looking into?
I think all of the AI stuff we talked about it already. I think that's going to be super interesting, super fundamental. I'm quite happy that we're in a place where we have sort of our traditional productivity metrics in a good place now, so we can actually kind of observe the effect of this, because I do think that that's the largest change that at least I have seen in computing in the last decades.
Amazing. All right, Moritz. I know we went a little bit over, but this was a fun conversation. Thank you so much for your time. And thank you, everyone, for listening. If you're interested in more developer experience or working in DevOps platform teams, we also run a community called Hangar DX. You can find more details at dx.community. We run virtual sessions there as well. And if you know some interesting people you'd want us to bring here on the podcast, please reach out to us. Until next time, again, thank you, Moritz, for your time. Really appreciate it. And yeah, have a good day.